Hi everyone, so it's great to be here. So my name's Jean, as Diarmuid said, and I'm going to be talking today about climate change and health. So essentially what I'm going to be focusing on is infectious diseases in a changing climate. Right, so this is a research-heavy one, right, so apologies in advance. It is the findings from a study that was very kindly supported by the Environmental Protection Agency a few years ago. I'm the principal investigator on it, called CRISIS, okay, which stands for Climate Change in the Republic of Ireland, Societal Impacts and Solutions. A very happy day when that acronym worked out, as you can imagine. And the project, which is now completed, was a kind of great success all in all. Okay, helping us kind of understand how, I suppose, the environment and climate change is impacting us. As I think you've probably got a flavour for today, this is a complicated kind of story. Climate change can impact human health in myriad different ways. Okay, the EPA threw money at this. It was great, but you could throw all the money in the world and you wouldn't be able to answer all the questions about climate change and health. So we focused on two different facets of health. We looked at infectious diseases and we also looked at mental well-being. Today I'm only going to talk about the infectious disease side, which I'm a little bit raging about because the mental well-being is a really interesting part as well, but you'll have to have me back at some stage to talk about that one. But we'll focus on infectious diseases today. Okay, so climate change, look, we all know the story, not great. Okay, we know that the climate is changing. We know that Ireland is no different. And as I think has kind of come across today, it was mentioned kind of multiple times, now the likes of the IPCC and most kind of health and environment kind of agencies truly acknowledge that this is going to impact our health. In one way, that's a good thing, I think, really, because when we do talk about things like climate change, which can be kind of abstract, I think actually contextualizing it in terms of human health is very beneficial because people are inherently selfish, and once you start saying if the climate changes you might get an infectious disease or XYZ, people tend to listen a bit more. So when we talk about climate change and health together, I think it's a very kind of positive step to kind of changing things. Okay, so in Ireland, we're going to have a change in both our temperature and our rainfall. Okay, there's kind of no avoiding that now. It's a complicated one. We might have decreased rainfall, but higher intensity, whatever it might be. Okay. When we look at that, these things don't happen in isolation, and when we look at kind of infectious diseases, particularly ones that have an environmental kind of flavour to them, if we have a change in environmental factors like temperature and rainfall, it's not a crazy notion to say, will this also impact environmentally driven infectious diseases? Right, so that was our kind of primary question. And luckily, Ireland, for better or worse, is a good case study for this kind of research because we do have a kind of a high burden of environmentally associated infectious diseases. Okay, so we looked at these three. They're notifiable infections. And I should say this work is, because it's complicated, it's a collaboration of people, right? It's not just me plugging away at something. It was in collaboration with the HSE, Med Éireann, multiple kind of institutions, which is required to look at this in depth. And we looked at three infections. We have virotoxigenic E. coli, or VTEC, which is I suppose a very kind of prominent disease in Ireland. It is largely associated with kind of private well use and water, okay, although it can be foodborne as well. We looked at Cryptosporidium. Some people might remember the big Galway Cryptosporidium outbreak back there in 2007, which is very much environmentally driven as well. And then we looked at Campylobacteriosis, which is largely foodborne, but we were kind of assessing, was there more of a kind of environmental association with it too. Okay, so Ireland has, for many years, had the highest incidence rate of certainly VTEC, very high levels of Cryptosporidiosis as well. So we had a lot of kind of data to kind of play with, right, which is good, okay, because all science is predicated, I suppose, on having good data to kind of go with it. So thanks to our colleagues in the Health Protection Surveillance Centre, we got access to the computerised infectious disease reporting system, and we were able to kind of pull out primary cases of infection. Okay, so this is very much epidemiology in action here. So we had Cryptosporidiosis, VTEC, and Campylobacter, and you can see we had quite a number of cases for each of these three diseases over a kind of a time period, right? And this means then that we can actually kind of do something, right? We can run analyses and things like that because we know where these happened, we know when. Okay, we removed any kind of cases that associated with being abroad and stuff like that, and all secondary cases were removed as well. So we were left with this very kind of big data set, okay, where we had geo-referenced cases of environmentally associated infectious diseases dotted kind of all around the country, okay? In terms of the methods, and again, I don't want to burden you kind of with this, right? This is just, I suppose, a little bit of kind of proof that I'm not pulling this out of nowhere. We did loads of different things, but I suppose the three kind of main ones is we did kind of space-time scanning, which, you know, if you're familiar with kind of any kind of epidemiology, and sure, we're all overused to it now after COVID and looking at where things are, we weren't just interested in where things are happening, but we were interested in where things are happening frequently. Okay, so identifying hotspots, areas that have a very kind of high burden of disease. And then using the data, we were able to kind of make these models where we linked all the cases of infection with meteorological data. Again, this was done in collaboration with Med-Éireann, so we looked at daily or hourly temperature and rainfall at the small area scale. This was a labour of love now for the poor postdoc who had to do this. Massive data set had to be kind of computed on a supercomputer kind of here in Dublin. So we had this really kind of high resolution data set of changes in temperature and rainfall and these infectious diseases. And looking backwards then, we can kind of go, was there a link between temperature and rainfall and the likelihood of those infections occurring? Okay, and if you can look backwards, it means you can look forwards, right? So we know our climate change projections for Ireland. Again, Paul Nolan's group and things like that have done great projections for what Ireland would look like in 2050, 2100 under different climate change scenarios. So once we have the past knowledge, we can project to the future and show what Ireland would look like as we move forward. Okay, so getting into the kind of the sexier side of it, right, the nicer kind of stuff. This is what the diseases look like when we do some space-time scanning. Okay, so this is VTEC, Crypto, and Campylobacter if we look at it spatially. And again, this isn't kind of where they're happening in any given year, this is where they're repeatedly happening. And as you can see, for all three infections, we have a fairly kind of abundant spread of the diseases. For VTEC, you can see it's kind of the Midwest here and up the Midlands. Crypto is more kind of countrywide, and Campylobacter is more down to the south, okay? The Midwest is screwed in all scenarios for reasons unknown. Sometimes I feel it's because I live there, right? But regardless, this is kind of the story we have. You'll notice that Dublin is pretty much unscathed by this problem, okay? And this kind of brings this whole concept of inequity again. And when we talk about environmental infectious diseases, it's very much a kind of a more rural problem in Ireland as it is an urban one. So while air pollution and things like that disproportionately affect urban areas, it's infectious diseases that is maybe the other side of that coin. Okay, it's more of a non-urban issue. Okay, so here's where you get a bit kind of more complicated, but once we kind of had the data sets together and we connected it with the temperature and the rainfall, we could then kind of make models to see, okay, looking at all those cases, which are real people, you know, which I feel like we often lose context of, we can see where they associated with temperature and with rainfall. And if we look here, so if we look at VTEC, we can see that there very much was an association between VTEC and temperature, okay, and this is the odds ratio, and all this is saying is that for every increase in 1 degree temperature, you're almost 7 times more likely to have a VTEC notification. Okay, so very much a temperature link with VTEC. Similar with Crypto, although the odds ratio isn't as high, and the same with Campylobacter. So temperature is definitely impacting these three diseases going on the cases we have. When we look at rainfall, we have a similar story. It's statistically associated with VTEC and Cryptosporidiosis. So for every millimetre increase in rainfall, we're seeing an increased likelihood of an infectious disease notification. Okay, that odds ratio is quite small, it's just over 1, but this is per millimetre, right? And we all know Ireland's weather, the difference between 2 days is rarely 1 millimetre, okay, it can be 10, 20, whatever. Okay, so we very much do. You'll see the rainfall drops off for Campylobacter, rainfall doesn't seem to be a driver. Okay, to look at this, I suppose, in a kind of a future perspective, right? And this is where it gets kind of interesting. This chart here, which is busy, okay, is showing the small areas. So there's 18,000 small areas in the country, a bit more than that, but there's a lot of them. And this is looking what happens to these infections if the temperature increases as we move forward. Okay, so in the center here at 0, it's kind of the status quo, and you'll see as you go up to 2-4 degrees, you see way more small areas now having a case of disease. Okay, so we're going to get this increased kind of burden for all 3 infections. So it is very likely we're going to hit 2 degrees. Hopefully we won't reach 4. If we reach 6, we've other things to worry about. But regardless, we will be probably in a 2 degrees warmer world, and we are going to see more notifications of these diseases, right? This is too difficult to understand, and this is a public health problem. Okay, we can't. If you ever have to over-explain something to anyone, it just won't sell publicly. So we made a big effort to change these visuals into something that people can understand. So that's what this looks like in a different kind of perspective. So again, you have 0 degrees, kind of where we are at the moment, and this shows the cases of infections under the different kind of temperature thresholds. Okay, so you'll see that this is for Campylobacter, you'll see that in a 2 degree warmer world, much of the country is going to have cases of these notifiable infections across the putting huge burdens on the public health infrastructure and all that kind of stuff. Okay, we did similar for rainfall. And again, we just did this with crypto and VTEC because Campylobacter wasn't really an issue. And again, projecting into the future, if we do get increases in rainfall, we're going to see an increase in both Cryptosporidium cases and VTEC as well. Okay, so we're going to see it with temperature and we're going to see it with rainfall, right? So 117% increase for VTEC over the same over a period of time. Okay, looking forward, right? And again, it makes no sense to kind of look at it that way when we can look at it this way. This is what it looks like under increasing rainfalls, 20 mils and 40 millimeters of rainfall, and you see that the burden of the area affected by VTEC is going to increase. Okay, Dublin still remaining a little bit unscathed, but regardless, there's other people outside Dublin, as we know. Okay, we're going to see much larger incidences of these infections. Okay, so it's very, very clear now that climate change will have an impact on the public health in Ireland. It is going to increase the incidence of these 2, maybe 3 infectious diseases, which we already have a high burden of, which does put a lot of pressure on the public health system. It is disproportionately affecting some parts of the country. It does disproportionately affect children as well. So children are far more likely to get a VTEC case, for example. Okay, so it's multifaceted, I suppose, when you take it all together. Just some conclusions from it, right? So just to, I suppose, tie it all kind of into one slide. For crypto, it's mostly driven by rainfall, okay? So we should expect to see a higher frequency of winter rainfall events, and we will see kind of Cryptosporidiosis cases that go alongside with that. For VTEC, it is temperature and rainfall, right? So we have the perfect kind of storm going on here, right? So in a warmer, wetter Ireland, we're going to get more cases of this disease, which we already have a high kind of prevalence of. And for Campylobacter, it is associated with temperature, doesn't seem to be associated with rainfall, and it's going to increase as well, okay? So there's an urgent need, I suppose, to do kind of more forecasting to try and anticipate what's going to happen, and crucially to try fix it. Okay, so while we can't stop the rain from falling, we can't stop daily temperatures from changing, there are obviously other things we can do to circumvent this. Okay, and one of the, I suppose, the things that we can manage, what I haven't talked about, is, private well use, for example, is one of the dominant risk factors for getting VTEC cases. Okay, you can do something there. They can be regulated much, much better. Okay, agriculture always comes out as a key risk factor for these infections, as a source of the diseases, right? So there's something to be done there in terms of management. So there are kind of things that we can fix, right? But it's just very important to be aware that this is kind of happening and there has stuff to be done. The way I kind of take it from its overarching kind of perspective is that climate change is a kaleidoscope issue. Okay, and we think, Joe, you tend to think of it maybe in the kind of abstract, rising sea levels, stuff like that, but it is very much affecting human health as well. Again, we're going to see that as we move forward. It's a global problem, but it has very local consequences, and we're going to see that, I suppose, as we kind of move through time. So thank you very much for listening. Just again to thank the EPA for funding this. There's a lot more to the project as well, but didn't have time to go through it all today. And if you have any questions, you can feel free to give me, you can talk to me here if you'd like, or you can give me an email. So thank you very much.